Hey, today we're going to talk about Threadpools in Zig. So I've got an open source project that I'm working on called HTTP Spec. We've talked about it a couple times on the channel. So if you are not new here, you're probably at least a little familiar with what it's doing. So I'm not going to go through that. It's not really relevant. And we'll talk a little bit about it as we go, where it becomes relevant. But what I want to talk to you about today specifically is Threadpools. So, okay, I've got my editor here. We're just going to go ahead and fire up Vim and go into our main.zig here. We're going to do a couple different things. Really quick high-level walkthrough. Better spot for it. Okay, so we pull in the standard library, we pull in clap. Clap's a command line argument processor. I think that's what it stands for. Command line argument something, if not processor. Parser, maybe. It's fantastic. It's really, really great. We pull in some files that we've written, an HTTP parser and a client, and an assertion checker. Okay, so with that in mind, what this does is this parses HTTP files, makes an HTTP request based off the information from that parse, and then runs assertions on that HTTP response based on the assertions that are captured in the HTTP file that we parsed originally. So we parse something that has information about the request to make and the expected assertions. We make those requests, and then we check to make sure that the assertions match. Really straightforward. So what I want to do today is we have a little piece down here where we really start to get into things, right? So this piece right here. We have a couple different things. We probably should pull this out into a struct. In fact, I think we're going to have to at some point, so we'll probably do that too. And this needs to be cleaned up. So we iterate through every file that we have, increment the test count, do some writing to standard out here that we probably don't need. We can just go ahead and toss that for now. We do that parsing that I mentioned. We create an HTTP client. And then down here, for each item that we have in an HTTP file, worth mentioning, you could have multiple requests in the same HTTP file. That would be like sequencing of requests. So you might do like a setup and then like an assertion and then maybe a teardown. So like create a user, assert that the user has some permissions, and then remove the user might be a scenario that you might do. Anyways, we execute and then we do an assertion checker, right? And if we catch an error from the assertion checker, we say, hey, this has a failure. Down here, we check to see if there is a failure. Test pass and test don't pass. I want to thread this, right? I want to run this against the thread pool, because right now we run this serially, and what we can see is that this runs kind of slow. So for example, let's save that. We'll come back here. I actually have VS Code up in the background. I was doing a little bit of finagling, and this is super quick. I'm just going to create 16 copies of our test case. So now if I come back here and do zig build run, it'll find all of the files in our subdirectory, and you can see it's doing them one at a time, and it's going slow, and it's going slow. So what I'd really like for us to do is run those all at the same time, because they shouldn't depend on each other. That's part of the requirements to use this successfully, is that your requests shouldn't depend on one after the other. If you have a sequence where you do have a request that depends on another, that should be in the same file. And we'll run the ones in the same file linearly. Okay, so how do we fix this, right? So we have a couple different things. So we know we have to keep track of test count, test pass, and test fail. To do that across multiple threads, we need to synchronize them. So I'm going to use a mutex for that. It seems like the simplest solution at this point in time. And to do that successfully, I'm going to need to pull this out into a struct. So what I'm going to go ahead and do is we're going to actually create a new file here. So I'm going to make a directory called source, not HTTP file. We'll call this reporters. Source reporters, and then I've got like a test reporter.zig. Okay, I'm going to go ahead and pull in the standard library. And essentially, we just need to create a struct that is going to model our test output for us. So we can do pub const basic reporter And this is going to be a struct. It's going to have a couple fields like test count, which is going to be a usize, test pass, which will be a usize, and test fail, also a usize. And then we also, I don't have a case for this yet, but I know that when we start multi-threading, we're going to run into a scenario where we could error out. And one of the interesting things about a thread pool is the function that you're calling against a thread pool can't return an error. So instead, we have to handle all of those errors inside of our multi-threaded function. So in that case, we just want to increment like the invalid count. So something went wrong, and yeah. I'm going to create a mutex. I'm just going to call it M, standard thread mutex. Hopefully you're familiar with mutexes at this point. I'll leave this up on the screen. In case you're not, feel free to pause it and read it. But the idea here is that we can essentially block a thread's access to something by using a mutex. Okay, I'm going to create an init method just to make things nice and simple. It's going to return basic reporter. And this needs... my formatting is very off. This is going to return... that's why the formatting is off. So this needs to return a basic reporter. And I'm actually going to simplify this. I've started using the anonymous structs here, and I tend to like those a little bit more when the return type is inferred directly above. Okay, so let's define our test count, which is going to be equal to 0. Our test fail, which is also equal to 0. Test pass is equal to 0. Test invalid is equal to 0. And then the last thing we need to new up here is our mutex. So we're going to go ahead and say standard thread mutex and just create that struct right here. And we need a semicolon right here to wrap that up. And one right down here. Cool. It looks like our LSP is picking things up, which means we don't have any syntax issues, which is great. I'm going to open main.zig because I have some reporting logic in here that I would like to grab. Yeah, this piece. So what I want to do is come over here and just, we're going to yank all of that. And then hop back over to our test reporter. And I'm going to create a new method called report. And it's going to take a self pointer to a basic reporter. And it's going to take a writer, and that writer is just going to be an any type. This will return void. And all I want to do is paste that here, except we want to just change this to writer.print. And then this will be self.testCount, self.testPass, self.testFail, and then finally self.testInvalid. And we need to add that up here as well. So we're going to add a new multi-line or a new string to our multi-line string, and it'll be invalid, and it'll take in a digit. Okay, feel pretty good about this for now. The reason that I pulled everything out to a struct, will that format for me? Format, please. Yeah, perfect. Okay. The reason I pulled everything out to a struct is generally when working with a mutex and a value that is like, we lock the mutex, we adjust the value, and then we unlock the mutex. I like to put those behind functions. It makes sure that we're always unlocking the mutex like we would expect. We're locking and unlocking in sequence, and everything's really nice and dandy, because if you lock a mutex and forget to unlock it, you can find yourself deadlocked. And we don't like that. Okay, so I'm going to create several functions here. I'm going to create pub func inc test count. And what this is going to do is increment the test count. So self, and we want a pointer to a basic reporter, void. And this is going to be the pattern that we kind of use for just about, actually, it'll be the same pattern we use for all of these. I don't think there's any changes that we'll make. So we're going to lock the mutex, defer self im unlock. And then what we need to do here is self dot, which one is this? Test count. So we'll take test count and we will have it plus equal 1. I'm going to go ahead and grab those and paste this same thing 4 different times. So we have increment test count, we have increment test pass. That'll be something like test pass. We have increment test fail, which will be something like test fail right here. And then we have increment test invalid. Yeah, so something like that. This feels pretty good. So now that we've done that, we've kind of pulled our reporting logic out. We're going to hop back over to main.zig. And in here, we're going to go ahead and just swap out all of this to use that reporter that I've just created. I think that'll kind of simplify things, and then we'll make sure that that still works. And then if it does still work, we'll actually pull things out to a Threadpool and use a wait group as well, I think, because we need to wait for all of the threads to complete to do our reporting. So, whoops, that was not what I wanted to type. Go for the 1 instead of the Q. Take me back up here. Actually, main.zig, please. Thank you. Okay, so let's go ahead and pull in our test reporter. So we called it test reporter. Reporters, test reporter.zig. Perfect. Feels pretty good. We'll come back down here and we're going to create a reporter. So it's going to be a test reporter.basic reporter.init. Okay, that's going to give us a basic reporter to work with, which is all we need at this point. So we need to change a couple pieces of our code right here. We don't need any of these values anymore. And instead of test count, what we're going to do is we'll do reporter.increment test count. Same with test pass here. This will be reporter.increment test pass. Same thing here, reporter.increment test fail. And we don't have our test invalid scenario that we're worried about yet, but we'll get to that in just a minute. Finally, we're down here with our writer that we've copied over. I'm just going to go ahead and remove all of this because we don't need that. And instead, what we can do is do reporter.report. And then standard.io.get standard out. Writer. Should take care of that. I feel like this should still work at this point. So what we're going to do is give this a run. Report cannot return an error. Let's clean that up. So in source reporter, test reporter. Oh, we're catching the error and then we're returning it here. I feel like we could just try and return an error. I don't see any reason why we can't return an error here. So we're just going to try to do the writing. Whoa. And this can return an error. That seems reasonable. So we'll go ahead and do that. And let's give this another run. Error unions ignored. Totally makes sense. Let's fix that too. So main.zig, I think it said 99. Yep, we can just come down here and try to do this. Maybe we should handle that differently at some point, but for now, just trying it should be fine. Cool. Okay, it's still running. It's still running serially. And we've added those mutexes, but again, it's running serially, so it's not like we have to worry about mutex contention or any of that fun stuff at this point. So yeah, let's do the fun stuff now. Fire back up our main.zig. And I think what we're going to want to do is essentially pull all of this out into its own function. So I'm just going to go ahead and highlight all of this using visual mode. Come over here, delete, or I should say cut, I guess. And then I'm going to create a new function called run test. Probably can come up with a better name for that. I don't entirely know what types we need to take in yet, so we're just going to paste that and we'll fill it out as we go. So, okay, so we know that we need a reporter. We also, I see an allocator in here, so I know that we need an allocator. So we're going to do standard mem allocator. We need that reporter that I just mentioned, test reporter dot basic reporter. And then we need what POS is. POS is not a good name. And in fact, we should change it. So it's a path, a file path even. So it's going to be a const u8 file path like so. Yep, perfect. We're going to change that to path. See if anything else is used anywhere around here. Unused capture on 24. I don't see an unused capture on 24. Oh, weird. Yeah. Or what, so line 24. Yeah, so this is, we'll need to call this function too. That totally makes sense that there's an unused capture. We'll come back to that in a second. So I think we have everything that we need here. The tricky part here is that we can't try anything, right? So I mentioned this earlier that in a thread pool, our thread pool has to run, our thread has to run successfully, or our job that we're delegating to our thread pool has to run to completion. It can't return an error. So to support that, we have to handle our errors in our run test function. So I'm just going to catch an error here. So if we fail to parse a file, all I want to do is reporter.test invalid. Wait, sorry. Inc test invalid. This is kind of an interesting one. Same thing here. Catch reporter.inc test invalid. And we need to return, right? We can't really continue without these things, so let's just go ahead and return as well. This one's kind of interesting. If we're not able to owned slice on our items here, that's kind of not necessarily an invalid test. That could be an issue on our end, or they could be out of memory on their machine. There's a lot of different options as to what could be causing that, but the invalid test might not actually be correct. We'll leave that for now, but maybe we'll come back and fix that at some point or change it. Okay, we're looking for try keywords. We have another try right here. So we're going to change this one to catch. If we can't execute the request for whatever reason, reporter.inc test invalid, return. And again, this is another one that maybe is not actually an invalid test, and maybe it's an indication that something else is wrong. But for now, we'll just count it as invalid. Okay, I don't see the try keyword anymore in this function, which is great. Let's come back up and change this to path instead of POS. And now we have to call it, right? So what does this look like? So we have a couple different options. I did mention that I want to use a Waitgroup and a Threadpool, so we are going to do that. So we'll have our pool and we'll call spawn Waitgroup on it. We need to give it a reference to a Waitgroup. What else do we need? Run test. Weird. Run test. And then we need the arguments that we're passing to run test, which is going to be an allocator, our reporter, and then our path. Obviously, we haven't defined our pool yet, so let's do that. But to do that, I feel like now's a good chance to remove this comment that says this is completely serial, and ideally we'd span across multiple threads. So let's do that. We'll remove it, and we'll place it right there instead. All right, so we have a couple different things we're going to create. The first one's a pool, and it's going to be a standard thread pool. And we can just go ahead and set that to undefined. And then under that, we want to do try.pool.init, and we can pass this some options. So we need to give it a couple items. So the first one is that we need to give it an allocator. We're just going to pass in the allocator that we're using for everything else. And then a number of jobs. So I'm going to set this to 4 for now. We can, sorry, I should keep this on the previous line. We can do defer.pool.dinit. And now we need to create our wait group. So I call this WG. It's going to be a standard thread wait group like so. Yeah, go ahead and new it up. I think that should cover it. So we have our wait group. Everything formatted properly. LSP is not complaining. This feels pretty good. Let's give this a run. So in theory, we should see like 4 of these firing off at the same time now. And it should get through things a little faster. Yeah, it in fact did. Except we're seeing an interesting dilemma where it says all 0 tests ran successfully. It tells us that it passed 0, failed 0, and had 0 invalid tests, and then they all run. So we have an issue, and after seeing that, I immediately know what the issue is. But we are not using our wait group. So we're passing things in to our wait group, and it's being managed for us, but we actually need to call wait group wait. I think that should take care of it. Give us another run, and we should actually see it work this time, I hope. Yeah, perfect. All 16 tests ran successfully. All 16 failed. That is by design, I guess, technically. Yeah, we could change a couple of these. So like if we change this one to 404, it should actually match. So let's run it again, and we should see 1 passed and 15 failed, which is the case. Excellent. So yeah, we're doing our thread pool with the wait group and some multi-threading in Zig, which feels awesome and actually really straightforward to use. One of the things that I think would be nice to wrap this up, though, is I have a hard-coded 4 right here. Well, right here. I'm going to add a comma so that formats onto the next line. I don't really want to hard code anything. So what I would prefer to do instead is make this a variable. So we have a variable called threads. We can pull that from an environment variable. Seems like a great spot for it. So what we're going to do is something like const threads is equal to, this is kind of interesting because we can avoid an allocation here since we are working with an environment variable that has a known key at comp time and is an integer. So in our case, instead of having to do like, oh my gosh, it's standard os.get env map or standard process.get env map. So instead of doing this and getting an entire map of all our variables, we know we just need one. So what we can do instead is do standard process parse env int, like so. We know that our comp time key is going to be something like http thread count. Seems like a good name for it. We can come up with whatever we want, but I'm just going to go with that. And then we need to give it a type. uSize seems fitting. And then we need to give it a base 10. This can return an error, so let's just catch if that happens, and what we're going to catch is a 1. So if we do have an error, instead of whatever we were trying to process, just use a 1 instead. So if we can't parse that environment variable, single thread it. And this will also default to being single threaded. Another option is, we could try to get the thread count on the machine and make a reasonable decision based off of that. For now, single threading it, if that's not set, seems more than reasonable. Okay, so in theory, I think that should take care of it. So what we should be able to do is a couple different things. If we run this again, we should see everything run serially. It does. If we run this again, but before we do, we set our HTTP thread count to 4, we should see it run in blocks of 4, which is great. And then in theory, if we set it to something like 16, they should all fire off at the same time. Pretty neat. Okay, so yeah, actually, I think that covers it. This was much quicker than I expected, which was great, but we've parallelized part of the processing for HTTP spec using Threadpools, Waitgroups, and Mutexes. And we pulled things out to a reporter struct, which feels nice and clean as well. Hopefully you found this video helpful. If you did, I would love to know what you found helpful about it and what you're hoping to learn more about with Zig. I know the documentation's kind of all over the place right now, so if there's something you want to learn about how to do or you want some more examples of, let me know. I'm enjoying making those type of videos, so happy to do that, especially if I can find a way to work it into an existing project that I'm working on. If you haven't yet, subscribe to the channel. We're all friends here. We're so close to 5,000 subscribers, and when that happens, I'm going to open up a Discord server. So I've actually already created it. I've put it together. I'm a little nervous about the floodgate of making it public, but when we hit 5,000, I'll share a link and we will make it happen. Besides that, I think that's it. So yeah, have a great day.